I am Alperen from NOKIA Data Center Pre-Sales, coming from Netherlands for Netnod meeting today. It feels great to be in here. And in this one, I'll be talking about how we're building modern scalable data center fabrics. Basically, I'll be drawing it from the latest engagements we have this year. So I want to start from talking about data center network evolution a bit. When I first made this slide, I put 80s, 90s, but then I said I was just a kid in the 80s, 90s. So let's start from what I experienced firsthand. 15 years ago, when I started building data centers, gigabit Ethernet was the thing, and we were building it with 1 gig, 10 gig switches. And the objective was to build loop-free data centers with a spanning tree. I remember connecting all the devices via CLI for configuration and SNMP traps for the alerting. And looking at the latest data center I worked on, I would say we are about here. So we built it with 800 gig switches. I think that's not a surprise anymore because that was mentioned quite a lot of time. And on the tech front, we moved away from layer 2 to layer 3 technologies. So we see more and more people are building their data centers with BGP and EVPN VXLAN. And on the operations front, today everyone is building it with some level of automation. But ideally, we go for intent-based automation. We have programmable network operating systems and using event-driven automation. So looking ahead, we're now looking into 1.6 tera switches. You may say, what's the hurry? I mean, who needs that? But I think you may guess that now the AI workloads are demanding quite a lot of speed. So this 400 gig, 800 gig, and 1.6 happens very quickly because of the GPUs that they can generate that amount of traffic on the network. And it's not only speeds, they also bring some new challenges and trigger us for innovation. I think we've seen a dedicated session on SRv6 and microsits, and that's what we're considering, as well as some advanced BGP features for the data center fabrics. And on the operations front, now we're looking into AI-driven operations. We're getting AI ops integration to our element manager systems and automation platforms. And now it's not only speed, technology, operations, it's also the scale of these data centers are getting evolved. Now, looking at the biggest data center in Europe like 12 years ago, and the one today, we see a big difference in size. And again, today, many 200 megawatt or more data centers are being built today, and all, again, triggered by the AI supercycle. And in the future, we're now talking about gigawatt scale. If you see this 3 gigawatts big data center planned to be built by Korea, the south one. So it's enormous. It's almost the capacity that a mid-sized European country has in terms of power. But it's not really easy to build it like that, right? So there are some challenges, and the obvious one is power, right? You need to find new places that power is abundant, or new technology that can easily can power these data centers. Like if you are into stock market, you maybe realize these small modular reactors are, getting to the moon. It's just because of this. And cooling, the air cooling is not efficient enough anymore, and we cannot even just build this scale data centers with air cooling. If you get an air-cooled GPU server today, it is 8 rack units because of the cooling. then we see industry is moving towards the liquid cooling, which you can have the same server in 4 rack units. And of course, the third thing is networking, and that's what we're going to be looking a bit more into this session. So here's some AI deployment examples of us, and here I'll touch on 2 things. First, training clusters, and then the inference clusters. Training clusters are where we just get all these GPUs, thousands of them, and they work together on building one AI model. And we try to get the lowest latency as possible, so we try to keep our designs in 2 tiers, so flat as possible. So any GPU talking on these networks will be quickly reaching each other. So if you look at the scale perspective, we see 2 different scales, right? We see gigascale, which can be Microsoft OpenAI, XAI, kind of hyperscalers, but also Giga AI factories are planned to be built in Europe. Those are more than 100,000 GPUs. For us, more than 100,000 high-speed endpoints. And then there are smaller training clusters. There's nothing small about them. It's still hundreds of switches, but when I place them next to Giga, it's smaller. So it's 1,000 to tens of thousands GPUs. For them, we can keep them in 2-tier topology. But when we go to gigascale, now we need to add the 3rd layer, which brings more latency. And at that point, we had to be a bit, we need to be thinking out of box as a whole community. And the idea came up actually from OpenAI is that to use multi-plane topologies. So there, what we do is basically to get this 2-tier topology and replicate that by 2, 4, or 8. So meaning that you are building 8 fabric, isolated, separated, and then having your endpoint, GPU endpoint, which is connected with 800 gig, and you split it to isolated fabrics. So in that case, you can connect more than 100,000 up to 1 million endpoints to your network and keep it in 2 tiers. And the other thing is inference edge clusters, inference where the AI model goes public in production and to be used by the end users. There it is more close to what we have today as edge cloud, so we need to distribute them as much as possible so they are as close as possible to the end users. So how do we get our networks ready for these new workloads? So I'll zoom into 2 things. First, we'll talk about between data centers, and then we'll see inside data centers. So we've seen these data centers are huge, and there was this power problem. And it's very common that we don't have these data centers in just one location. We may have them in multiple locations. In this case, you build your data center wherever you find the power, right? And it could be the case that you don't have any other infrastructure there. In that case, we see ZR coherent routing is very practical to connect your data center to the network. It can, in that way, your data center can be hundreds of kilometers away from your network node. And we talked about the AI workloads, and it's very common that they communicate and synchronize between data centers with elephant flows. And we talk about now we are connecting them with 800 gig switches. In this case, we use flexi bundles to connect smaller interfaces to a big, giant, huge bandwidth interface. Like if you have about 800 gig elephant flow between 2 data center, you can pass it through a flexi bundle. And when we zoom into the data center, so I'll talk about three things here. Scalability. So you see the scalability challenge. So now we have hundreds of thousands endpoints in the network in the same fabric, and they require high bandwidth, right? In this case, we are using our 800 gig high port density switches to connect them together so that we can keep it as flat as possible, the network. And losslessness is critical. I mean, imagine 1,000 GPUs working on a task, on iterations, they are synchronizing with each other. And if you drop just one packet, the impact of that is actually multiplied by 1,000, because all the other 1,000 GPUs are going idle. So in this case, this network has to be lossless, no tolerant to loss, and we're actually ensuring that with advanced load balancing and QoS features like dynamic load balancing, RDMA array hashing today, and with DCQC and QoS features. But as you've seen during today's sessions, this is not the point we stop. Right? We are considering SRv6 microsits for a deterministic path, or BGP, DPF, or Ultra Ethernet transport to help us further in here, optimizing the network. And the other thing is very important, that we cannot go blind with this scale, right? When you have hundreds or even thousands of switches in a data center, you need to have some intelligence in your telemetry system, right? It's, first of all, the SNMP is not the way anymore, and if you go with the telemetry, there should be some intelligence in your telemetry platform to show you what's going on, right? So some AI integration on the telemetry is important for the relevant insights from the network. And the last one, but important one, backend multi-tenancy. So if you are Microsoft, OpenAI, xAI, or Meta, that kind of hyperscaler, you can build a giant data center and just use it for your own application. But many others, especially the Giga AI factories are being built in Europe, will use this Giga factory by the tenants. So you'll have multiple organizations consuming it, so on the GPU level and on the network level, you need multi-tenancy. And when we talk about multi-tenancy in network, first thing to come to mind is the VPN VXLAN. But we try to avoid using it as it brings more overheads. And we know that GPUs are trying to make use every bit per second of the capacity that they have. So using VXLAN actually shrinks your bandwidth by 1 to 2%. So we try to use a lightweight solution there based on VRF light and route leaking. So all of these could be seen a bit intimidating compared to how we build the data centers today. And what we prefer to do is to have all this intelligence and put it into an automation system. So when we need to roll out these networks, it is able to do it for us. So here we see everything in one picture, from bottom to up, a reliable data center with its simplified operations. Then the data center gateway is becoming critical when we need to connect these data centers each other. Of course, we need optical connectivity and solid IP connectivity that allows us to pass the elephant flows. And of course, security is one of the things always that we consider, DDoS protection, and an intelligent automation system and telemetry system at top. And this is how we are building it. At the very bottom, Today we are using IXA data center platforms based on the Broadcom chips, and mostly the Tomahawk and Jericho goes for the latest data centers. And on top, we use a Linux network operating system. It gets its protocol stacks from SROS with added programmability. And at the top layer, we're using event-driven automation to automate all the things that I've mentioned so far. And as a last point, I want to talk about the contributions we've done to the open source community. So when we bring this SR Linux network operating system, we, in short time, we made it publicly available for the trial. So, and then our engineers bring this GNMI client for our use, and then we also made it public for community to quickly adopt it to the telemetry. And the container lab is also something we've done internally and then made it public. And today, it's a great success that we see many people are using it. And I really wonder if any of you heard of container lab before. If you can raise your hand, perfect. Some people, oh, quite a lot of people. Great. So it's not only NOKIA, it's multi-vendor. So almost every you can roll up your virtual network, virtual lab with almost any vendor, including firewalls and your telemetry stack. And at last, we released IDA as an automation platform, and it's becoming multi-vendor at the end of this year as well. And it's also publicly available, so you can try IDA without any license, any registration, or without contacting anyone from NOKIA, actually. And that's all I have to say. It's a great time if any questions.
So we have some time for questions. Any questions for Alperen?
Perfect.
Okay.
I would glad to meet you in the social events afterwards. Thanks a lot for listening, and have a great day.
Thanks for a great presentation, Alperen. Thank you so much.